we have another application of implicit differentiation, and this application is the derivative of, or derivatives of, our inverse trig functions. Okay. And so we'll list them out here real quick, and then we'll prove one of them, and the idea that's used to prove it can be used to prove the other 5. Okay. So let's see here. The derivative with respect to x of sine inverse of x is 1 over the square root of 1 minus x squared. And this is for x less than 1. And I should be a little bit more specific. Numbers whose absolute value is less than 1. Okay. And this has a lot to do with the fact that our trig functions aren't all defined for all x. For instance, the domain for, and I'll get rid of this here in a second so it's not in our way, for y equals sine inverse of x is only from -1 to 1 to begin in the first place. So its derivative is still defined for -1 to 1, but with the endpoints excluded here. Okay. So not a lot's changed. Okay. Then for cosine, or inverse cosine, the derivative is -1 over the square root of 1 minus x squared, and this is for the absolute value of x less than 1. Yeah. If we move on to the derivative with respect to x of tangent inverse of x, that's 1 over 1 plus x squared, and this is for all x. And the derivative with respect to x of cotangent inverse of x is -1 over 1 plus x squared. And this is for all x. Okay. In our last pair here, the derivative with respect to x of secant inverse of x is 1 over the absolute value of x times the square root of x squared minus 1. And this is for the absolute value of x greater than 1. And then let's look at the derivative with respect to x of cosecant inverse of x, and that should be -1 over the absolute value of x times the square root of x squared minus 1. And this is also for the absolute value of x greater than 1. Now that we have all these new formulas here, let's see where they come from. So what I want us to do is just start off with y equals sine inverse of x. Okay. We don't know the derivative of, well, we kind of know it now, right? But if we were trying to come up with this, the derivative of sine inverse of x, it might be helpful to actually take sine of both sides, or to just note that if y equals sine inverse of x, then it must be true that sine of y is equal to x. And then the next thing we could do is, well, we do know the derivative of sine, so we could use implicit differentiation. We could get cosine of y times y prime is equal to, and the derivative of x with respect to x is just going to be 1. Let me just point out what we did here. Implicit differentiation. And then we'll go ahead and we'll solve this thing for y. And how about y prime instead? Y prime equals 1 over cosine of y. Now, this is not the formula we had up here. Okay. See if we can fix this. So we know, I'm going to draw a triangle here. There we go. So what we're about to do is base a triangle on the fact that sine of y equals x. And I'm going to actually scoot it over a little bit so we don't mix it up here with our work. So I just want us to be thinking about sine of y equals x. Well, that tells me that if I'm thinking about this angle y, that the opposite side, right, sine is opposite over hypotenuse, the opposite side should be of length x, the hypotenuse should be of length 1, and if we use our Pythagorean theorem, this other side should be 1 minus, or the square root of 1 minus x squared. Okay. And so what that's going to allow us to do is use this triangle here to now compute cosine of y. And cosine of y is supposed to be adjacent over hypotenuse. So if we take that adjacent side to y, that'd be this. And we divided it by the hypotenuse, which is 1, then we just finally get that the derivative is just equal to 1 over the square root of 1 minus x squared. Okay. And this matches our results. Up here, we have the derivative with respect to x of sine inverse of x is just equal to 1 over the square root of 1 minus x squared. Now that we're on to page 2 here, we're going to practice using these new formulas for our derivatives of our inverse trig functions. And there's one thing I'd like to point out here before we even start this one, is if we were to have arctangent of x, all that means is tangent inverse of x. Okay. It's just a different notation. And depending on what textbook you're using in physics or math will depend on which one of these two notations will pop up more. And this arc notation applies to the other inverse trig functions as well. For instance, cosine inverse of x could also be called arc cosine of x. Okay. Now, one more thing we might want, it's just a little note here, is what the derivative of arctangent was, or tangent inverse. Well, it was 1 over 1 plus x squared. Well, note, there's not an x in here, right? There's an e to the t. So this means we're going to have to use the chain rule. Our inside function is e to the t. So we'll have 1 over 1 plus, and rather than it being t squared, it's going to be e to the t squared. And then from here, we still need to multiply by the derivative of the inside function, which is e to the t, right? The derivative of e to the t is e to the t. All right, and that's pretty much it. We can rewrite it a little bit, though. I could multiply and end up with that e to the t on the top, And down here in the denominator, I could rewrite this as 1 plus e to the 2t. Let's try another one out here. So here we're going to need to use the product rule. Let's get started. The derivative of x with respect to x is just 1. And then we have times our second function, which is sine inverse of 3x. Then plus x times the derivative of sine inverse of 3x. Let's just remind ourselves of what that derivative looked like. And by that I mean the derivative of sine inverse of just x. This was 1 over the square root of 1 minus x squared. So rather than writing 1 over the square root of 1 minus x squared, we actually have a 3x in here, right? So this is going to look like 1 over the square root of 1 minus 3x squared. Then we still need to multiply by the derivative of the inside function, which the derivative of 3x is just 3. And so we have now found our derivative. Let's rewrite it a little bit. So y prime is equal to sine inverse of 3x plus 3x all over the square root of 1 minus 9x squared.